Let's talk about how we get the mechanical advantage of levers. Now, Trent, you know that you've been reading along here. You know that there are three classes of levers: first class, second class, third class. And it turns out you pretty much you use the same technique to calculate the mechanical advantage of all three. And as we go through that, hopefully you'll see that. So here we have in front of you a first class lever. A first class lever will have an effort on one side of the fulcrum and the load on the other side, and that's what we have here. Now, terminology, the words we choose to use. I tend to use a little bit different terminology, little different words. I think of this as the input side of the machine, and this is the output side of the machine. And everything I think that happens on this side I call it input, and everything on this side, I think of it as output. So I'm going to say that when you push down with this force, I'm going to say that is F in. And the force that you want to come out, which is called, other places call it the resistance, I'm going to call that F out, okay? And that it's just, I'm doing it the same way everybody else does. Okay, so how do you get mechanical advantage? We need to identify, okay, mechanical advantage, it is the ratio of the force that comes out divided by the force that comes in. But I don't know those, and in fact, I want to predict those. So what I need to do is use the technique of taking the ratio of D in over D out. So how do I get D in and how do I get D out? Let me go ahead and erase some of this stuff so that it looks kind of less. So basically, we've already talked about the effort, resistance. I use the term output force. We already know all this. Okay, enough of that, enough erasing. Okay, because basically I just want to make that clean so we can see it. What you need to do is find your fulcrum. So for all three classes of lever, it's the same thing. Find the fulcrum. Then, what is D in? D in is the distance from where you apply your input force to the fulcrum. So this is D in. That is the input distance. What is the output distance? You can probably already guess. You're going to figure out where the force is coming out of your lever. That's going to be centered on the load, whatever it is. And then you're going to basically go back to the fulcrum, say, where is it? And then this is going to be D out. So let's do a calculation for this lever. Okay, we're not going to take measurements. We're going to count blocks. Okay, so we're going to count these blocks. So with D in, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Great. Out comes the calculator. Okay, so that's 11 blocks. So over here, I'm going to put 11 blocks. What is D out? 1, 2, 3, 4. So that's 4 blocks. So down here, I'm going to put 4 blocks, whatever the units were. If I'd done inches over inches, centimeters over centimeters. So what's 11 divided by 4? That goes into, oh gosh, I know this, 2.25. So that is the mechanical advantage for a first class lever. Find the fulcrum. Find where you put the input force. Find where the output force comes out. That's going to be the load, whatever you're lifting or moving. And then basically measure the distance from the fulcrum to each of those points. D in is fulcrum to load, input force. D out is fulcrum to where the load is. And what's the price we pay for this mechanical advantage? This mechanical advantage, distance. So you're going to have to push down, you're going to have to push down further than this thing comes up. Okay, there's always a price we have to pay. So